In this problem, the subsets given an integer array nums of unique elements return all possible subsets, also called the power set. The solution set must not contain the duplicate subsets. Return the solution in any order. So they have given the array. We need to find out the all the possible the subsets. So here the subsets are like nothing but we can consider like a subarrays, like those are the part of the array, but the order is not required. Like we should only check whether it is like left to right. Suppose you can take the empty and you can take 1, you can take 2, you can take 3, you can take 1 2, you can take 1 3, you can take 1 3, you can take 2 3, like that all the possible subsets. And also they told we need to store the array list, and we need to return such that the answer also need not to be in a specific order, like 1 2 3 1 2 1 3 1 2 3 3 or empty, all these whatever the order we need to store and send. So this problem typically we can't solve by through iterations, but we can solve by through recursions. So how the recursions here works means we need to consider 1 2 3. Suppose if you take, the core idea is when you take 1 2 3 we need to consider all the possibilities. So so typically how the recursion is work means, if you take first we will do here the binary recursion. Like the logic is like first we will include the present element, like we will include the present element, and we don't include the present element. And then we will go and we will check where the next element, like 2, and we won't include the very next element, like 1 only. Again the same thing, we will include the second element, and here again the current element we will not include, again empty. So similarly 1 2 it will go 1 2 3 and 1 2 and 1, because now it is pointing to 3. So this is the overall the flow of the code. So if you try to understand the code, basically there the base condition is whenever we go the bottom, the index we will keep on increasing. Whenever it reaches the length of the our array, we will just store it in an temporary array list, and the temporary array list we will add to our answer array, and we will just return, because the given answer will write one more function void and we will do these operations. Here we have two recursions. The first recursion, like I told, we will include it, we will add the subset. Here is the temporary, we will add the present element, and then we will go further, and the next time we will exclude the current element, and also the temporary will include previously that we will remove it. So then we will again keep continued by adding the index. So so if you observe in the diagram, it will be very good understanding. So first this is the base, it is a starting function. So nums of 1 2 3 and starting initialize with answer 0. We'll consider the first element, like in the 1 2 3 we will consider this first element, and like we will add here, we will add to the subset, and we will call again one more dfs. So this is again one more the dfs again. So if you keep continue, then we will, so this function will call, and this function again two times it will call. So this is a recursion, this is a binary recursion. So again it will call, so it will go down so the next time again the same dfs function. This time the nums is same but index is increased, and the subset are having the 1, and also resultant we are not added. So the same again we'll call the dfs here. Again again the dfs again two times it will be called. So here the pointer will again go to the index, the next index, like that. Whenever it reaches the base condition, the result we will store and will add to the answer, and again we will go back to the function, like it will just return to the previous function, so it will go back to this function. So that's why it's called the backtracking. It's an backtracking problem. Again we'll consider the next function. Again it will go and again it will go to the starting. It will complete all these functions again. Now once it's done, again it consider the second recursion, like exclude the current element. We'll again starting 1 2 3, we will remove the starting element and we'll just take the empty array, and again it will call again the same it will be again the new function, new recursion functions is calling itself again. So again the DFS part will be start. So it is typically like a iterations, but here it keep calling itself functions the two times. So that's why it's a binary recursion. The time complexity is 2 power n. So here you can check the next time, then 1 2 3 we will again if you take empty, we will again take the current element and we will exclude it, and again 2 if you take, we'll take the current element and will exclude it, the current element. This is the code so this is the code we just discussed now. You can check the code.